Hello everyone. So today we are going to solve this LeetCode problem, which is check if a string contains all binary codes of size k. What this problem says that we have been given a binary string s and an integer k, and we have to return true if the binary code of length k is a substring of s. Otherwise, we have to return false. So let's see with this example here, our k is equal to 2, and so the all the binary codes of length 2 are 0 0 0 1 1 0 and 1 1. So we have to check if in our this binary string, which is 0 0 1 1 0 1 1 0, it contains all these binary codes. So see, it contains 0 0, yes. It contains 0 1, yes. It contains 1 0, yes. And it contains 1 1. So it contains all these four binary codes, so we'll return true. Okay. So this is what this problem is asking us. Okay. Now let's see how we'll solve this. Okay. So what we have been given a binary string s and a integer k. These two things have been given. Okay. Now what we have to check, we have to check the all the substrings. What are all the substrings? It is 2 raised to power k. This will give us 2 raised to the power k. This logic is used to find the power of k. It will left shift 1 to the number of bits, and this contains the power of k. Okay. Suppose k is equals to 2, then it will left shift to 2, and this will give us 4. Okay. So this was the logic. Okay. Now what else we'll take? We'll take a bit set of 2 raised to power 20, which is 104856. Okay, and we'll give it a variable as c to check we have covered all the binary codes or not. Okay, then we'll take another variable mask to check how many code we have iterated over. It is required minus 1 initially, and another variable hash equal to 0. It will give us the current substring code. Okay, so what we'll do, we'll iterate over our binary string, which is int I equal to 0, I less than s dot length, and I plus plus. Okay, now we'll update our hash with our current substring, which is hash left shift 1, and with current value of mask, and or with the rightmost position of I initially, it will contain 0, and we'll end it with 1. It will give us whatever the value of si is, and this will give us our current substring. Now we'll check only if I is greater than equal to k minus 1. Okay, because only then we'll consider that length. Okay, and it should not be present in our scene bit set. Okay, then what we'll do, we'll update that position with 1. We have found one string, so the required string that we have to find, we'll decrease it, and if required is equal to 0 and we have found all the substrings, then we'll return 1, not 0, 1, which is true. Simply we can write true also, 1 also. Okay, so return true. Okay, and if after iterating towards entire string we haven't found all the substrings, then we'll simply return false. That's it. So this was our core logic, what we have done over here. Okay, what we have done, we have let's take an example and see what we have done over here. Suppose our given example, which was this, s is equals to this binary string and our k is equals to 2. So what we have done, we have checked if all these possible required number of binary strings are present as substrings in our original giving binary string. That's what we have done over here. Okay, this and this we have done, it shifts the previous bits to left. And what does end of marks do? It removes the extra bit, keeping the length to k only, because we have to find only those substrings whose length is k bits. And what does this part does? It adds the new bit from the right side. Okay, so I of s of I and 1 does add the new bit. So that was the core logic. If you have any doubt, just put it in the comment section or any suggestions. Keep learning, keep growing. Bye bye.